order to find an explicit formula for this pattern right here, you kind of have to envision what's happening with these subscripts. And you can see that the numerator always matches the subscript. So that's why we have it in here. And the denominator always has the subscript plus 1 minus 1 over the subscript plus 1. So there's your explicit formula right there. Now, if you want to get a little more simplified version, multiply numerator and denominator of that complex fraction by n plus 1. That's the one denominator that appears to make this a complex fraction. In the numerator, you get n times n plus 1. In the denominator, you get n plus 1, the quantity squared, minus this 1 right here. And if you simplify that denominator by squaring that binomial and subtracting the 1, or combining the plus 1 and the minus 1, you get n times n plus 1 over n times n plus 2. These n's cancel out, and there's your explicit formula right there. Over here, we can confirm that that's what's happening with this table on Desmos. They give you decimals here, but here I did b of 300, and you see it's 301 over 302, n plus 1 over n plus 2. And to find the limit as n approaches infinity of this a sub n or b sub n, you can rewrite that n plus 1 over n plus 2, divide every term, numerator and denominator, by n, and this is what you get right here. And then as n approaches infinity, these fractions, 1 over n and 2 over n, approach 0. So there's the limit. And that seems to be what's happening right here. As n gets bigger and bigger, this number is going to get closer and closer to 1. You can get as close to 1 as you want. You'll never actually get there. That's why it's called a limit. There you go. Hope that helped. If you have any questions, post a comment.